Hydrocarbon compounds 2. Hydrocarbons, types of compounds. There are two types of compounds. Saturated compounds. They contain the maximum number of hydrogen atoms per carbon atoms. These two examples, they are single bonded and they are called alkanes. The other type is unsaturated compounds. These are compounds that contain double or triple carbon-carbon bonds. In here, double bonded is alkenes and triple bonded alkynes. Alkenes. They are named in the same way as alkanes, but two things changed. One, they changed the ending of the parent chain from ane to -ine. In here, we have ethane and ethene. Second, we have to add the number of the first carbon where the double bond lays as a prefix to the parent chain. In this example, 4 carbons will be butene, and the double bond begins in the second carbon, that's 2-butene. Alkynes. They are named in the same way as alkanes, but two things changed. One, change the ending of the parent chain from ane to -ine. In here we have ethane and ethyne. And second, add the number of the first carbon where the triple bond lays as a prefix to the parent chain. In here we have 5 carbons, so it's pentyne, and the triple bond begins in the second carbon, so that's 2-pentyne. Aliphatic hydrocarbons. Straight chain and branch chain alkanes, alkenes, and alkynes are considered aliphatic hydrocarbons, where the major attraction between them are the weak forces, van der Waals forces. As a result, their physical properties do not change dramatically, such as boiling point. Isomers. There are compounds that have the same molecular formula but different molecular structure. There are different kinds of isomers. The first one is structural isomers. These are compounds that have the same molecular formula but they are joined together in a different way. In here we have butane and methylpropane. Both of them have 4 carbons and 10 hydrogens, but they are arranged in a different way. They differ in physical properties, such as boiling and melting points. The more branch, the less melting and boiling point they will have, and chemical reactiveness. So reflect. A branch isomer would boil at a lower or a higher temperature? And the answer is a lower temperature. The other isomers that there are is the stereoisomers, and these are compounds in which their atoms are joined in the same way, in the same order, but the position of the atoms in the space is different. In stereoisomers, they can be geometric, where atoms are joined in the same order but different in the orientation of groups around the double bond. In here we can see we have butene, and we can have cis-2-butene or trans-2-butene. In the cis meaning in the same way or in the same side, we have the methyl group in both sides in the same way, whereas trans means across, so the trans will be, both methyl groups will be one across the other from the double bond. And the other ones, stereoisomers, are optical, when a carbon atom has 4 different atoms or groups attached to it, and it will produce like a mirror, or you will find a mirror of it. Cyclic hydrocarbons. These are carbon compounds that contain a hydrocarbon ring. In here, we can see the loops of hydrocarbons. And then the first one is 3, so that will be cyclopropane. 4, cyclobutane. 5, cyclopentane. 6, cyclohexane, and so on. The boiling point, as we can see, is the bigger the carbon ring, the higher the boiling point will be. And this is because of the forces of attraction. The forces of attraction between them, although they are similar for cycloalkanes, the London dispersion forces that they have, they sum up, and that causes a greater area of contact. Ring strain also causes certain cycloalkanes to be more reactive. So back again, the more hydrocarbons that will have more reactiveness. Aromatic hydrocarbons. These are compounds that are responsible of the aromas of spices such as vanilla, cinnamon, cloves, and ginger, etc. These organic compounds contain a benzene ring or other ring in which the bonding is like that of a benzene. And let's meet benzene. Benzene is formed with 6 carbons and 6 hydrogens. We can see it in here. And it's an hexagon, obviously. Benzene was discovered by Frédéric Kekulé. In a benzene molecule, the bonding electrons between carbon atoms are shared evenly around the ring, and this is called resonance. We can have also substitute aromatic compounds. The dyes used to produce the intense colors are made with a benzene ring and substitutes attached to it. There are different ones, and here we go. We can have, for example, a methyl group, and it's called methylbenzene or toluene. We can have an oxygen and a metal, and that will be methoxybenzene or an antisol. We can have NH2, that is the group amino, and that will be aminobenzene. We can have NO2, that is the nitro group, and that will be nitrobenzene. And finally, we can have a halogen attached to it, and that will be the name of the halogen, that is in this case bromobenzene. Substituted aromatic compounds. To name them, start to assign a number to each carbon in the ring and separate them with a comma if the atom or group attached repeats. In here we have 2 bromos, so that will be 1,2 dibromobenzene. In the second case, 1,3 dibromobenzene, and in the latter, 1,4 dibromobenzene. Now is your time. Here are 3 structures. Stop the video, and when you're ready, play it back so you can compare your answers. Good luck. Thanks for watching.